In particular, the last take-home message, so to speak, that you can sort of try to solve several problems at a stroke. So the next framing presenter will be Zbigniew Klimont. Actually, my Polish scientific assistant told me how to pronounce your name, and I think it was okay. So you are concerned here at IIASA with, precisely looking both at the mitigation of air pollution and greenhouse gases. So I guess you will follow up on what Klimont just told us. So please go ahead.
Yes, to some extent I will follow up on that, what Klimont said, and try to extend a little bit on that. Ladies and gentlemen, Mr. Chairman, about 10 years ago, a bit more than 10 years ago, Jim Hansen, scientist at NASA, published a paper in which he proposed a strategy to reduce some of the air pollutants, like black carbon, that is a strong warmer, leaves very shortly, remains for a short time in the atmosphere. A strategy that could help to keep climate change in check, he proposed. A strategy that has been controversial and remains to be controversial among many. Exactly 10 years later, upon initiative of UNEP, and I'm happy to see today Joe Alcamo with us, the chief scientist of UNEP, who has been participating in the previous session, who was one of the initiators of that effort. An international team of researchers revitalized, in a way, that idea, looked again into the same idea, and added an array of issues. And now I will talk about that, but what's more, I'll say first a few words about something that IIASA is good at: integration across sources, impacts, and different scales. On this slide, you see a concept of co-control of greenhouse gases and air pollutants. On the top scale, you see reduction of greenhouse gases moving actually from left to right, and associated reductions of air pollutants. So it is very good to do that, and it brings benefits on many different areas. Air pollution, like health associated with air pollution, or crops, and I'll come back to that on one of the later slides. One of the key problems, however, is that not so many or very few countries see that as a very important on their agenda to reduce greenhouse gases up to now. And it does not, such policies, climate policies or co-control policies, do not address the key problems, priorities of the developing world. This map is actually a composition of two maps that my colleague Keiwan has just shown. Basically, it shows a difference between high pollution scenario and the low pollution scenario. This map demonstrates priority for developing countries in terms of health protection. The red areas depict high concentration of pollutants, both now and in the future. As a matter of fact, if we did a similar simulation maybe 3 decades ago, I'm quite certain that Europe would have been a very red area. And actually, this kind of analysis was actually at the heart of some of the work at IIASA. Looking into local problems, we have constructed together with member organizations, institutions in member organizations, the RAINS model at the time, about 25 years ago, and started to look into issues, local issues associated with air pollution, health impacts, vegetation damage. That's a very simplified slide pointing out to the connection between an array of air pollutants, sulfur dioxide, particulate matter, and a number of health impacts and vegetation damage impacts. This model has been extended over time, and we have added greenhouse gases. And as indicated on one of the previous slides, there is a strong connection between the two. Emissions occur largely from common sources, so there is this co-control impact that is very important. Having that framework at IIASA we have been able to analyze different elements of and impacts and co-benefits of climate scenarios. This is a fairly dense slide, but if we focus on the left side and see these dark blue bars, the higher the bars, the worse it is. This is showing increase in crop losses of some major crops in China compared to the year 2005 in a baseline scenario by 2030. On the right side, red is bad, indicating higher losses of soybean as an example here in this baseline scenario. The light blue bars indicate the impact of a climate scenario. Obviously, there's a reduction due to co-control. And small animation running here points for the soybean that a number of areas turn yellow from red or turn into green. That's a good thing. However, there's a lot of areas that are still red. And as shown on the previous map with the health, the high priority for a number of governments in both developing and developed countries will remain to reduce these impacts at the local level. And therefore, a lot of priority and efforts will be put in to reduce the compounds that are contributing to that. So what we're going to do, what we have done, we went back to the drawing board, starting from the structure that you have seen, the Gaines model, and extended it to include another impact, near-term forcing or near-term temperature increase, and indicated here next to air pollutants as well as greenhouse gases, little pluses and minuses. I owe you a little explanation. Ozone, black carbon are warming. Sulfur dioxide is cooling. This is very important to take into account in the analysis. This also opens up an avenue to extend this analysis to include other problems like rate of temperature increase, adaptation of societies and ecosystems, or tipping points, Arctic ice, for example. We have run the model to analyze measures that contribute both to warming or reduce warming and improve health, and rank them according to their warming potential, and identified 16 measures that are listed on this slide that are reducing about 90% of the warming within the potential we identified from the short-lived forces. We have no time to go through these measures, and that's not the point. I just want to highlight a few of them, like improved stoves, so crop burning, or oil and gas industry, as well as diesel particle traps that would help. The point is that these measures are practical measures, largely applied in several regions of the world. The challenge remains, of course, to apply them widely and reap the benefits of these measures. This was put into a climate modeling exercise employing two models, a GIS and ECAM model. And in this chart, the two lines indicate the baseline scenario and the climate scenario from which we have taken CO2 measures, and you see a trajectory that starts to decline, missing the 2-degree target, which is indicated by this pink area. And it even peaks actually higher above the baseline within the first 2 decades, owing to the fact that we are removing a lot of sulfur aerosols at the same time, which are cooling. So what we've done later, we have put the scenario that I've just shown, the 16 measures. We put emissions that are calculated with implications of these measures and exploring full potential of these measures. You see, there is an offset, a significant offset compared to the baseline scenario, and a very quick reaction to these measures because their lifetime in the atmosphere, they live very shortly in the atmosphere. It includes methane, precursors to ozone, and black carbon. However, that blue line that I have shown previously was still shooting through the 2-degree line, only in combination with the CO2 strategy, and there's no excuse not to do and enter very early the CO2 mitigation strategy. The chances increase to reach the 2-degree target. Of course, this is a simulation done with 2 models, on a particular set of scenarios, but we believe that's a fairly powerful message, and we should not forget that that was impact on the temperature, but we will quite certainly have a lot of co-benefits, a lot of local benefits, both on crops and air pollution. On this slide, you see that the highest health benefits will be in the developing world.
Okay, thank you very much.
Can I just add one slide?
No.
The last one. I'll just leave the last slide. I'm sorry for that delay of a minute. This is the result of that work that resulted in a political agreement, and I'll just leave you to read that.
Okay. We all love Hillary Clinton, so thanks a lot.